So let's go on to the next point. Let's say that you're given this data set. So let's say that you're given this data set, but you notice there's a lot of repetition on the numbers. And I asked you just to find the mean or the average. So regardless of whether this is a population or a sample, you find the average in the same way. Add up all the numbers, divide by the number of numbers, right? But let's say that you had the same data set, but it was represented a little bit differently, where I represented this data set as a table of two columns, where on the first column, I only list out the unique numbers. So what are all the unique numbers? Yeah, 1, 2, and 3. But for each unique number, now I want to specify, if I want to actually specify this data set, I need to specify how often each of these unique numbers occurs. So the 1 occurs 4 times, and the 2 occurs 5 times, and the 3 occurs 6 times. And so you notice that this first column represents a certain value in the data set. So this is X, and the second column represents how often each one occurs, but in this case, it's a raw count or frequency, so I can call that F. So this same information now is depicted a little bit differently as a table of these two columns, and this should look familiar. This is what we just finished talking about, which is a distribution. This is a frequency distribution. So let's say that I asked you to find the mean of this frequency distribution. Well, the mean of this frequency distribution is nothing more than saying what is the mean of these values if they were all listed out in this list format. So whatever the mean of this frequency distribution is, it should be the same mean as if I were to list them all out the appropriate number of times. So one common mistake is just to add up these 3 numbers and divide by 3. So why is that wrong?
It doesn't count how many times each number is represented.
Yeah, you're not accounting for the actual number of occurrences. So you can't just add up these 3 numbers and divide by the number of numbers. So you know that in the end of the day, you have to add up all these numbers the appropriate number of times. So the 1, we need to add up 4 times. So another way of saying that is 1 times 4. And then we have to add up the 2 5 times. So another way of saying that is 2 times 5. And then we have to add up the 3 6 times. So another way of saying that is 3 times 6. And then we need to divide by the number of numbers. So how do we get the number of numbers quickly from this table?
You add all the frequencies together?
Add up all the frequencies together, very good. So add up all the frequencies together, which is 4 plus 5 plus 6. And that would represent the mean of this frequency distribution, which represents the mean of this variable x. If each value of x were distributed, the number of times it corresponds to the second column. So this is the mean of the frequency distribution, or also this is called the mean value of x in the frequency distribution. Okay, any questions so far? All right, so this is how we find the mean of the frequency distribution in this example with these specific numbers. But let's generalize this. So if I had given you a table of 2 columns, no matter how many numbers there are in each column. Let's come up with a formula together to try to find the mean of this frequency distribution. So we know in this example here that I'm taking 1 times 4, and the number 1 is the example of the first x. So this will be x1. And we're multiplying that by this 4, which is the first frequency, so we'll call that f1. And then now we're adding this 2, which is an example of the second x, which is, we can generalize it with x2. And then that's times this 5, which is the second frequency, which is f2. And then times 3, which is an example of the third x, which is x3. Times the 6, which is f3. So then, if this had more rows, then this would just keep going. Now, how do we generalize this? So each of these terms that are being summed here has what structure? You're just multiplying a certain x in a certain row times the frequency, or f, in the corresponding row. So it's x times f, and you notice that in the summation, it's consistent throughout. So it's x times f plus x times f plus x times f. So when we generalize this as a formula, this will be up top here, this will be the summation, because we're adding all these terms together, so there's going to be a summation. And then each thing that we're summing up has what structure? It's x times f. So it'll be the summation of x times f. So this notation here is a compact way of saying this entire numerator. And then that's going to be divided by, how do we generalize what we're doing in the denominator here? Yeah, the sum of all the f's. So because we're adding up all the f's together, so this will be summation, all the f's together. So this is the formula that you'll see in your book for the mean of a frequency distribution. You're adding up this product of x times f, and then whatever that is divided by the sum of all the f's. Any questions so far? Okay, and so this f stands for frequency. But you can also think of it as each of these x values are being weighted a certain way. So for example, this one that occurs 4 times is being weighted a little bit less than this 3 that occurs 6 times. So these f's can also be called weights. And because of that, this formula that we just came up with, this is also called a weighted mean. So this is called a weighted mean, which is the same as the mean of a frequency distribution. Any questions so far? So in the time we have left, let's quickly do another related example. So let's say that in the semester you're taking different classes. So and each class has a certain number of credits associated with it, and each class has a certain grade that you'll get in the class. So let's say that you take one class which is 5 credits. And because that class is so many credits. Let's say that you study really hard for it. And let's say that you get an A. So that's your grade. But let's say that you take other courses this semester. And let's say that you take another class that's only 1 credit, like bowling or whatever. And so let's say that this class is only 1 credit because it's worth so much less compared to this other class that you kind of blow it off. And let's say that you get an F in that class. And let's say that you take another class that is 3 credits. And let's say that you get a C in that class. So the question is that at the end of this particular semester, what would be your grade average? So the question is, can you just add up these 3 grades and divide by 3? Yeah, what's that?
Because they're weighted different.
Because they're weighted different, because this class that is worth 5 credits is, whatever grade that you get is gonna be worth a lot more than this grade that you got in the 1 credit class. So we're gonna calculate the grade average. We said that we can't just add up these 3 and divide by 3. Now we're gonna, basically, because each grade is weighted, we're gonna basically have to use the weighted mean formula that we just talked about together. So, right now we only have letter grades, so let's convert them to their conventional numbers so that we can add them up and find the averages. So, this A corresponds to how many points conventionally? Well, no, so if you get a 4.0, for example, that means you get straight A's, right? So an A corresponds to 4 points. And then an F corresponds to?
0.
Yeah, 0. And then a C?
3.
That would be a B, so 2, yeah. So 2.
But what's the D then? It's like.
D is 1.
Oh, okay, never mind.
Yeah, yeah. So we said just that to find the average grade, we can't just add up these 3 grades and divide by 3. If we did that, then what would we get? We'd get 2. So the correct grade average should be higher than 2 or less than 2 or equal to 2.
Higher.
Higher, why is that?
You got an A in the 5 credit class?
Yeah, this 4 points that you got in the 5 credit class is gonna weigh a lot more than these other grades. So the real average is gonna be pulled up closer to this 4. So you would expect the real average to be higher than 2, as if all these were rated the same. So you can think of it as this A is being listed out 5 times, and this 0 is being listed out once, and this 2 is being listed out 3 times. So to find the average, you just add everything up in the list and divide by the number of numbers. So in this case, this 4 points is being listed out 5 times, so you're gonna multiply that number 5 times, or add it 5 times, which is multiplied by 5. And this 1 is gonna be added by itself, or this 0 is gonna be added by itself 1 time, so now we're gonna add a 0 in, but technically times 1. And this 2 is gonna be multiplied, is gonna be added to itself 3 times, or multiplied by 3. And then we're gonna divide by the total number of numbers. And so, what's the total number of numbers? Okay, so it's,
9.
yeah, so it's the sum of all the weights. So in this case, it'll be 5 plus 1 plus 3. And so this is a little bit tricky, is that we know that we're supposed to use the weighted mean formula, but the question is, so we have 2 columns here, X and F. So which column should be our X and which column should be our F? So, to answer that question, it depends on what you're trying to find the average of. Here we're trying to find the average grade, and so the column that remains is our weights. So the credits here is our weights. And the thing that we're trying to find the average of, which is the grade, that's our X. And so basically, when we're dividing by the total number of instances here, in the formula, we're dividing by the sum of all the F's. So here, we're gonna divide by the sum of all the credits, which would be the 5 plus 1 plus 3, which will be the 9. And if you punch this in real quick, what is the grade average that we're supposed to get? So 20 plus 6 is 26 divided by 9. So this looks like a little bit less than 3. This looks like 2.9 something. So just like we expect, the real average will be greater than the average as if you weighted all these grades exactly the same. Okay, any questions?